Okay, Year 9, let's solve some current and voltage problems in electrical circuits. So, two rules. One when you have a series circuit, when you have a parallel. So a series circuit is just one loop with your power pack or your battery or something. And a parallel, remember, is where you have more than one loop. Okay, so for example, there's two ways that the electricity can go around. In this one, it can go around that way, and it can go around that way. So you could have a parallel circuit with 3, 4, 5, up to infinity many loops in there, and it's still a parallel circuit. A series circuit, one distinct loop. Okay, so the rules are, for the series circuit, one distinct loop, that the voltage is shared between the components. So the voltage of the power gets divided between all the components. So if you have one component in there, it gets all the voltage. If you have two exactly the same, like two light bulbs, they halve the voltage. If you have three the same, they each get a third of the voltage. So with a parallel circuit, the voltage does not change between the components. So if the battery is giving out 6 volts, 6 volts go to this strand and 6 volts go to this strand. Okay, but the current in this one, the current is shared evenly between the components. Let's do some examples to talk through it a bit more. Okay, so this first example, we have a series circuit because the main circuit here is just one distinct loop. Okay, so we've got a series circuit, and voltage is measured across our power source here, and it's given as 6 volts. Okay, so 6 volts is evenly shared between anything on this series circuit. Okay, so we've got 3 light bulbs that are exactly the same, so they need to share the 6 volts evenly. So 6 divided by 3 equals 2 volts each. Okay, so 2 volts, 4 volts, 6 volts make up the 6 volts given out by the power pack there. Okay, so voltage in series is shared between the components. Current in the series, though, we've got another same series circuit, 3 bulbs there. The current in the circuit is measured up here on either side of the battery pack, and it's 6 amps, and around the globes also 6 amps all the way around. So it doesn't change, it's constant throughout the series circuit. So current does not change between the components. Okay, let's look at our parallel circuit here. So it's a parallel circuit because you can see there's one main loop there and there's a second main loop coming off it. Okay, this one's definitely parallel. Okay, so here the voltage does not change between the components, or does not change between the loops, I like to say. So this first loop gets 6 volts and this second loop gets 6 volts as well. Okay, there's one globe on this one, so it gets the whole of the 6 volts going through that loop, and there's one globe on this one, so it gets the whole of the 6 volts going through that loop. Okay, so voltage in parallel, each loop, each individual loop, I like to say, gets the full voltage. Okay, let's contrast it with current in parallel. Current in parallel is split. Okay, so you can see here closest to the battery, 6 amps is coming through, but after it splits off, it's divided by each split. So we've kind of got 2 loops here, so 6 divided by 2, each loop gets 3 amps, okay? Each branch gets 3 amps. Okay, what if the components are organized in series and parallel? Well, we still follow the same rules. Let's look at some examples. Okay, so here we've got a parallel circuit. We've got 2 loops, 2 possible loops. Okay, so let's consider just the voltage. Okay, so we learnt that each loop gets its 6 volts here, or gets the same voltage as the power pack. So 6 volts is given out by the power pack. This first loop gets 6 volts and the second loop gets 6 volts. If you look at the outer loop here, there's only one component on that loop, so it gets the whole of the 6 volts. But this first loop still gets 6 volts there, but you can see in series in that little loop is two components that are equal. So the 6 volts that go into that one loop in series are shared between two. So they get 3 volts each. Okay, so that first loop closing gets 3 and 3, which is 6, and this outer loop here, which just has the one bulb, gets 6 volts. All right, let's look at current in series and parallel. Okay, so what we notice here is same circuit, we have 2 loops. All right, so around the battery first, 6 amps is coming out. Okay, 6 amps, and so the current is shared evenly between the 2 loops. Okay, so this loop gets 3 amps no matter where you measure it on, and this loop here gets 3 amps until you come back to that main branch near the battery. Okay, so the splits or the branches each get half the amount because there's two loops or 2 circuits within that parallel circuit. Okay, so on the following slides, there's a variety of circuit diagrams. What you need to do is, well, let's not draw it in our book. We're working on the slides here. For any ammeters that do not have the value of the current, fill that in, and for any voltmeters that do not have the voltage, fill it in. Okay, I'm going to do a couple just to help you through, and then I'll leave the rest for you. So this one here, first up I noticed that it's got one main loop there. So we're dealing with a series circuit, okay? So the rules for a series circuit, I'm going to write down series circuit, it helps me out, is that voltage is shared, current remains constant. Okay, so let's do current first, because current remains constant. Look up here. The current is given 15 amps. So what I'm going to do is, I'll change colors because why not? Anywhere that there's an ammeter on this circuit, it must be constant. So it must also be 15 amps. Here's one over to the left, 15 amps. So it's 15 amps no matter where. Okay. The battery is given out 10 volts. 10 volts on the battery. And we've got our 2 components there, our 2 globes, 1 globe, 2 globes, they're equal, okay? So the voltage is shared. So 10 volts given out, and the voltage across the 2 globes must be 10 divided by 2. 10 volts divided by 2 equals 5 volts each. So I'm going to write here 5 volts and 5 volts. All right, that's everything filled in. Let's do question 2. What have we changed here? It looks very similar, doesn't it? We've got one main circuit. Okay, so it's a series circuit. So the same rules must apply. Current, or amps is constant. Voltage is shared. Okay, so let's find our ammeter. Our ammeter with a measurement is here, and we've got this ammeter here, and we've got this ammeter here with a blank, and this ammeter here with a blank. Voltage must be constant, and this one says 15 amps, so 15 amps for all of them, okay? Because it is a series circuit, voltage remains constant. All right, let's tackle voltage. Let's change the color. Maybe I should keep consistent colors. I'll go on purple. Okay, so the voltage given out by our power pack here is 15 volts. We've got 1, 2, 3 globes here, all sharing the voltage. 15 volts divided by 3 equals 5 volts each. So underneath each of them, I'm going to write 5 volts in my bad handwriting. All right. What I might do is skip ahead a bit. Well, nah, I won't skip ahead too much. I'll do this question 3 because now we've got a parallel circuit. Okay, it's parallel, and I can see that immediately because we've got one loop through back to the battery or power pack, and we've got a second loop through and back to a pack. So we've got a parallel circuit. All right, I might just get rid of those squiggles. So we've got it parallel, so current is shared between the loops, and voltage is constant in each loop. Okay, so let's do current. Looking up here, look at this current that's coming out of the battery pack, 15 amps. Okay, so it's shared. So we've got two loops, one current here, sorry, one ammeter there and one ammeter there, and we've got one here, okay? This one here is near the battery pack, so it's going to have the full 15 amps because they're coming back together. But each branch then after that, down here and down here, is going to have it shared. So 15 divided by 2, because there's two branches, so it's going to be 7.5 amps each. 7.5 amps. Okay? Okay, voltage is constant for each loop. Okay, so 10 volts is given out by the battery, so 10 volts is coming down there and 10 volts is coming down there. Okay, 10 volts is coming down here and we've got one component, so it must get the full 10 volts. Okay, 10 volts is coming down this branch too, and there's one component, so one component meaning one bulb, it gets the full 10 volts as well. Alright, I'm looking down here and it's not too much of a change, so I'll leave that up to you. Should I do any more? What I might do is this problem here for you, okay? Notice the difference. Instead of the numbers being given near the battery pack, they're given down near the components. Let's work it through though. We've got a parallel circuit with two loops, okay? Now, so for a parallel circuit, current is shared between each branch. And on the branch here, we've got 16 amps. So that must mean that each branch has the same. So that one there is, I drew 6. I want to go back. I want a 16 amps as well. So when they meet back together, anywhere along here, it must be the total because it's shared. So this one must be 32 amps and this one here must be 32 amps because they're both on the shared path of the two loops. Hopefully you can make sense of that language. It's how I write it, how I think about it. Okay, so we've dealt with all the currents, with all the ammeters. Let's deal with the voltage, okay? The voltage where we've got a reading is this one. We've got 8 volts across that bulb there, okay? It's the only component on there, so that must mean that 8 volts is coming down there. And so it must mean that 8 volts is also coming down that branch. And that branch here, this bottom one, only has one component, so this bulb must also see 8 volts, okay? And if 8 volts are going to each branch, because voltage is conserved in a parallel circuit, that must mean the battery pack is giving out 8 volts. Alright, so a little bit more difficult there. And this one looks like the same thing. Alright, and there's some extension questions too. Give it a go in your book if you can't do it digitally and see how you go. Hopefully that video helped you out with me rambling through and using my own language like loops, and each loop must have this voltage. Okay, thanks guys.